All right. Hey, welcome. I'm Agent Ultra, and for the next couple hours, I'm going to be here programming stuff in Haskell because that's what I do on the stream for the most part. We've been working on learning an algorithm called wave function collapse for a little while, and we have an implementation, working on a visualizer for it now. So we're going to try and wrap that up this week, hopefully. And yeah, maybe we'll save the last hour or so for doing some prep work on Advent of Code, getting my base libraries up to date, and checking out some new libraries we might want to use. See if we can't figure out how to use them, that kind of stuff. Just to be prepared. I don't know if I'm going to do it this year. I didn't really do it last year, but we'll see. We'll see. All right. So without further ado, if this is your first time watching, welcome. Thanks for hanging out with me and going on this little journey into the land of functional programming and algorithms and stuff like that. All right, so I'm going to open up the project here. I think where we left it off last week was we had it kind of running. It's a little slow, but we can fix that. But the main thing that I need to fix right now is I think that we're not quite preserving the raw pixel data appropriately. And that's kind of showing up in the output, where we just get like an all blue texture, and we kind of expect some different colors in there. There should be some different ones. So that's going to be in our from surface and to surface things. We're going to have to figure out the get pixel and set pixel functions here for getting and setting that data and doing the casts appropriately and getting the appropriate pixel data out. My suspicion is that we're just not reading enough data for each of the color channels per pixel, and like kind of not really putting all that data out properly from the format and then putting it back in appropriately in the right format, that sort of stuff. So we're going to learn a little bit about the PNG file format and the pixel data in there, because that's what we're using for our test data. All right, conceptually, a PNG image is a rectangular pixel array with pixels appearing left to right. Within each scan line, the scan lines appearing top to bottom. Makes sense. Okay. This might be the right one that we want. Color values. Colors can be represented either grayscale or RGB. I think they are RGB because we have a color one. Okay, RGB data represents calibrated color information if this chunk is present, or uncalibrated device-dependent color if this chunk is absent. Don't know all about that. I don't know if our library even supports that. Maybe it does. All color values range from 0, representing black, to most intense, with the maximum value for the sample depth. The maximum value at a given sample depth is 2 to the power of sample depth minus 1, not 2 to the power of sample depth. Okay. Sample values are not necessarily linear. Okay, it's not necessary. Source data, precision not just supported. Bit depth, okay. Grayscale pixel. 0 is black, and the largest value for the bit depth is white. Not 100% sure, but I think we were seeing 0, and yet it was the texture that we were getting back was rendering as blue in SDL. I wonder why that would be. True color pixels represented by 3 samples. Maybe because we're using true color. Red appears first, then green, then blue. The bit depth specifies the size of each sample, not the total pixel size. So even in that case, though, I think it would be black. Unless the C uint we're pulling out is getting like... And the C uint we're putting back is like a weird combination. Pixels are always packed into scan lines with no wasted bits between pixels. Pixels smaller than a byte never cross byte boundaries. They are packed into bytes with the leftmost pixel, the high order bits of a byte, the rightmost and lower order. Permitted bit depths and pixel types are restricted so that all case bytes. Okay, we're not so much worried about that. I just want to make sure, because we don't really touch the pixel data in it, like the color values themselves. I just want to get the whole chunk of data in a pixel and then put that in our thing. A pixel fewer than 8 bits in the scan line with is not evenly divisible by the number of pixels per byte. So either these are 16 or 8-bit. CUint might be a 32 or 64. How big is the CUint there? Foreign types. C char. CU char. CU short. CInt, CUint. Okay. So they're using the... this library is using the unsigned, like the platform-specific types instead of the specific ones. Can we be more specific? So the UCU long is represented Haskell-wise at least by a word 64, but I guess on the C side of things, just the platform-specific one, please. Let's not use the integer library. That would be silly. Okay, I'm not too happy about that. Maybe there are reasons for it I don't understand or I don't know. But as a C programmer, I would probably be using, I wouldn't be using onside car in modern code these days. I would be using the standard sized types. So that's disappointing. Okay. So, well, at least CInt is in 32. So, on the Haskell side, so, I don't know. Maybe with CUint, we're pulling in a 32-int, the unsigned int here, a 32-bit. If they are... Instead of 8-bit and 16-bit values. But if there's 3 of them, that would be 3 bytes. So that would be 24 still. Oh, plus the alpha would make it 32. So this should be fine. We look at our PNG file. Can't make it bigger that way. us. Oh my gosh. Yeah. Okay. There we go. Coming in, coming in, coming in, coming in, coming in. Blurry as heck in Emacs here. But like, I don't know. That color though, I don't think it's actually represented in the output that we've seen. So if I try to run the demos we have right now, let's take a look at that. Stack, sec, WFC test. Yeah, we need the image arg. And separate like that. Okay. Okay, we are seeing different pixel values here. Some of them are 0. Some of these like different 32-bit numbers. It's just a bit slow. So we should see an image with more colors. A few different ones at least. Oh wait, no. That's the... No, we're getting 0, 0, 0, 0, 0, 0, 0 here. This is the output texture. Okay, I gotta remember the debug here. Okay, so this is the output we're getting right now, which is not bueno, not good. This is problematic. Here. And then the set pixel stuff is a bit problematic too. Where's those debugs coming from? I guess I put them in the library. Source, algorithm, function collapse, boom, boom. Okay, I got my hello here for making our output texture. I think that's the only debug trace we have in here. So we must be printing out those. Yeah, print input texture. Okay, we call the run wave. And then we print the output WFC texture. Okay, so the output WFC texture has all zeros in it, so that's a bit concerning there. Well, maybe it is something with what we're doing, generating that thing. My from enum here is just should be just for the pattern index into our patterns, our pattern results. I'm gonna put out the pattern result, because I want to see. Yeah, in the construction of the pattern results, that if we are copying the pixel data we get from the textures and wholesale without any change. I'll get my builder going. We'll use the test run as our builder. We can keep that going in the background. No harm, no foul. Make sure we don't change anything we don't mean to change. Okay, chat. Swarm Collective. What's going on? Welcome back to the stream. Good to see ya. Tell me how you're doing. Tell me about your projects and what you're working on. Or what you're not working on. Glad to hear it. It's awesome. Okay, we can't show the pattern, right, because we don't have a show instance on the A thing here. And I don't know if I could force it on this part because I don't think it's on the type. Oh, good old CI/CD image running. Awesome. Okay, well, I guess it worked. It built. I was pretty sure that wouldn't, but there you go. Okay, so let's pop it up again. Well, let me make sure that I'm still actually streaming here. Okay, my stream preview just went down for some reason, but it looks like I'm still going, so great. It's been happening a lot lately, Twitch. I don't know what's up with it, but you gotta fix that. Okay, still doing his thing. Okay, so we got the patterns here. Okay, we look at these patterns and we see example 0022, 000, 0. Those are all the enabled? No, those are all the patterns, pattern data. Okay. Okay, so our pattern results looks like we're not chomping in the right data. These are all zeros, and I expect not so much of that happening. Right, okay, so we know where to look for this issue. Let's dig in there. I'm just going to get rid of that. Okay, pattern construction, patterns. This is where we get the pattern result. From a texture A. So it should, if we do this correctly, not change anything about the A's. Right. We don't have any constraints on A, so we shouldn't be able to do anything with it. Just copy it, a value of it. We can put a value of it from a texture into the pattern, output pattern. That should be the only thing we can do. But the other thing we could do is we can completely construct the pattern of A, ignoring the data in texture. That's possible too. Okay, so when we want to construct patterns, first we guard on the subpattern size. So if the subpattern size is 0, we just return an empty pattern result. Otherwise, we create some bindings here for something called up to, which gets the texture size of the texture -1. So some looks like a bounds there, right? P's, I'm guessing P's are supposed to be the pixels. Or maybe the patterns. Patterns, I think, because we call extract pattern here on the texture at X and Y for every subpattern size, where X is 0 up to and Y is 0 up to. Okay, and an extract pattern. All right, we got texture, text, pull the texture data, and let's see, we get W, again, size -1. Subpattern size. Okay. Suspect. Size, in this subfunction extract pattern, size might already be within modified for bounds, so we might be going a bound smaller than we need to. Potentially. Or that's correct. But anyways, suspicious about that. Indices. Okay, so we take A to be the value of X to X plus width. This size. W. And B to be Y up to including Y plus W. Okay, I could see how size -1 would be set there. Okay, and so we take A mod W and B mod W to be the indices. I think the indices were fine in the output for our patterns. Right, so go 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. And then 2, 0, 1, 2. 0. Yeah, so the zeros, the ones, and the twos. All square, square, square. That's all good. It's just the second element of that. So we get texture elements to be fold L over the accumulate elements function of texture, starting with the empty list, and the indices we just computed. So I think indices are fine and correct. Those seem to be good. It's the accumulating value, or the accumulating elements. Okay. So here we're going texture, we're banging into the array at X, the given index, and consing that onto the accumulator. Okay, and the input text here is the input, supposedly the input array of the whole input texture. If I put a debug here, it's going to print out a bunch of stuff. What would the X be here? The word. Okay. Can I limit it to the first X values? That would print out a little bit less. Yeah, that's we could try that. Okay, Haskell Kitty is here to say hello. Say hello, Haskell Kitty. Hey, say hello to the stream. Meow. Okay, she doesn't like saying hello, so. But she's here. She's here. Okay, you're gonna have to move out of the way though, Haskell Kitty. There we go. Yeah, so why don't we do that? Actually, I kind of want to put out, like, I think I know what the texture will be here. Fairly certain. Maybe if we just output the index values into it that we're trying to get. Okay. As we can see, only outputting a few. Few indices between 0 and 1, or some combination of them. So that right there is kind of smelly. So we'll kill that. And so still could be the size issue. Indices is clearly the problem. So indices here wants to be the subset of indices in the index space of texture that we want to put into pattern. So we get the values from the texture and put them into this pattern that we're constructing. It looks like this is... Why is this only going to 0 and 1 is my first question. Some combination of them. Well, if we're x to x plus width and our input x here is 0 and if our size, what would size be? Sub-pattern size. And in our case, I believe that will be 3. So it should be 0, 1, 2. And if that's not inclusive, then that's only going to go 0, 1. All right, oh, it is inclusive, so that would have to be... We'd have to be basically getting 1 there. Okay, so... Let's put a debug trace here, I'm pretty sure... Yeah, show indices here. I'll get the whole complete list of them. Yeah. Yeah, I think that would be it. Storm Collective. Yeah, I think the mod is there to try and make sure that those subpattern indices wrap around like a torus around the edges of the texture, which may not be, it's clearly not working the way we want it to. Because these are, for one pattern, these are the indices it wants to extract from the texture, and that's not right. Could be. Could be. Let's give it a shot. I think that sneaking suspicion was right. That inkling. Really, we should update our tests for this. That's all right. We'll just kind of do a quick little... Possibly better. Actually, let's just let that run out. Let's see what we get. Ah, there we go. Some different values. Still not quite what I was hoping for, but okay, maybe the pixel values are now at least being copied properly. Yeah, okay, so this is our output texture here. And that looks like it's getting some different data. All right. All of that. Oh yeah, a lot of output. Okay, so that was definitely part of it. Get rid of the debug trace. So I think our tests are not sufficient, at least for this particular case. We don't need W all over the place, really. Rid of that. Okay. Let's go to those tests quickly and just see if we can write a quick little one for that, just so we don't accidentally screw something up in our next change. Oh. We're only running the run wave test for now, it seems. We did break something, or at least an assertion on something. Building the frequency map. What did we break? I'm gonna get rid of the other debug tracers. It's making too much noise now. Bear, 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 bear. Yeah, just one failure. Frequency map, minimum frequency map. Error in array index. Here. Better frequency hints, pattern result patterns. Texture 3 should satisfy map. Holding over the map elements, key X and R. R and X should be greater than 1, should be true. Have to remember how old R works on maps. To understand how what that means. I think what this is saying is that the frequency map should not be, each pattern in the frequency map should be, have a frequency of at least 1. But we are getting an array index on this texture, access issue on this texture in that algorithm there. 0, 0 to 1, 1. Negative 6, 5, 6. Some arbitrary texture. Okay, that's our arbitrary texture. Right off the bat, that is 0, 0, negative 3, 0, 1, negative 6, 1, 0, 5, and 1, 1, 6. So I think the array bounds are off. Potentially on this. This might be a red herring of the generator. No, 1, 1 is a valid index, 1, 0 is a valid index, 0, 1, and 0, 0. Yeah, that's all of them. The generator's fine. We do have some kind of access issue there. Okay, let's just check that. Frequency hints. The list of patterns, generate the frequency hints from it. Good to do. So we start with an empty map and our patterns. Like first we take the patterns and we zip them together with a set of integers. So for every pattern they get an integer starting from 0 to the patterns. That should give us all the pairs of int and pattern like this. Then we map over that, or we do this recursive go function over that. Our accumulator here, I believe this is an accumulating function, yeah. So map.empty, here is an empty map with our initial input patterns. And what are we accumulating? In the empty case where there's no patterns, we return the accumulator. Otherwise, we have some patterns. We take the head of that list, X and P. We insert at index scene P of P's. And then onto the map, output map here, or the accumulator map. Or no, P's prime, the patterns list. So if we see this pattern in the patterns list already, accumulate it. P's prime of X's, okay, seen. Old L there. This could be a source of slowness in the algorithm. So we fold over here. We have scene X, and we're basically, I think scene is looking if this pattern here is in this list of patterns. How many times it's going to return. So fold out, count as accumulator y. So if the pattern y we're looking at is the same as a pattern x, then count plus 1, otherwise count, beginning with 0. Where are we indexing here? Error in array index. This error comes up from error in array index. This, ooh, I think this is one of the data.array things. So maybe it is the problem with the generator and this is a red herring. We've had problems with this before on the stream with this. Where does that error come from? There's two weirdly worded ones here. Error in array index and another one where they're very similar looking. How did I find it last time? Was it this post? I mean, that runs their debug exactly. Yeah, I think it's in the array construction. Potentially. This is where this one comes from. Although, where is it constructing the array in all of this? I don't know. No, this is constructing a map. Okay, let me just double check that generator then. Arbitrary texture. S to enum to S. Choose an in between 2 and 20. X's is an infinite list. Then we construct an array from where the bounds are 0 to 0. S minus 1, S minus 1. We take S times S from X's. So if our width, our S is 2, we're taking 2 times 2, which would be 4 from X's, so 4 elements. And our bounds would be 0, 0, 2, 1, 1, which would be 3 elements. 4 elements. Yeah, that should be right. Yeah. Okay, so that constructor list array is fine. Is it in the spec itself? We just changed pattern results. I don't know if we just broke it via a recent change. So let me bring this back to where we were with W. Let me do it this way. Yeah. Okay, so taking the W out there means that we're constructing, things a little bit oddly here. This is where it's coming from. This list array. Okay, so this I think is good. Taking out that, we get the correct indices. However, our list array here is not the right bounds. We just need to take the -1 off of that one too. Get 2 failures now. Hopefully they're the right ones. Okay, we break run wave and still break the minimum frequency map. Swarm collective. Psi should be used for the mod calculations. W should be used for the limits. Yes. Yes. This is the way. Well, the test runner will see. Will let us know. know, we're still kind of breaking something fundamental here. First, in that the frequency map we're creating isn't being constructed properly with the right bounds. So let's fix that first. So I think size... do x up to w, size -1. The number of elements and indices. Yeah. Let's debug that trace out here. Let's see. Extract pattern 2, extract pattern 2, extract pattern 2. All 2. Which is right-ish. Swarm is saying, did you intend pattern size? Or did that used to be pattern W, aka pattern size -1? Yeah. This variable here, yeah. So we expect when we extract the pattern from the texture for it to be... We want patterns of 3 by 3. That's the size of the pattern. And then the array bounds of that are going to be a little bit different. So that'll be size inclusive, like 3 by 3. That's going to be like, because the patterns are supposed to be square. But the array bounds would be then 0, 0 up to, in this case, should be up to 1. They're 3 by 3. 0, 1, 2. Yeah, so it should be up to 2 inclusive. And then, yep, no problem. So I think that W is the right value to be using there. So then we have to make sure the texture elms is the right length. Has the right number of elements. Alright, so this includes x, whatever x is, up to and including whatever x plus w is. So if we had w as size -1, which w is 2, essentially. This is x up to x plus 2. So if x is 3, this would be 3 up to 3 plus 2, which would be 5, which would be 3, 4, and 5. And that would be 3 elements. And then y would be the same thing. And that would give us 3 by 3, 3 times 3 elements. Like the 3 times 3 is 9. Which is what we should get. I don't know how this is still... Why is it still broken? breaks on exactly this example here. The other test failure is not quite the right, not going to be quite one. This is like the catch-all Big Daddy test. Integrates all of these functions together into the big, to run the whole algorithm on some example input. This error here, couldn't find a pattern to collapse to, is like a special kind of case where it's running through and it's doing a bunch of stuff on the cell data. And prematurely finding an empty cell or a value we can't collapse the cell to. Which might be because we're screwing up the patterns here. That's my theory. Either, yeah, it's got to be an extract pattern. All right, extract pattern. Show the length. Show me the length of indices. So 9, I thought. Okay, so 9, if W is 2, 2, that would work. Size would be wrong. Three failures now. Okay, we made it worse. Yeah, okay. So, yeah, that would be wrong. Undefined array element. Undefined array element. So yeah, we made it qualitatively good. Up to be sub to, okay, yeah. So our P's here could be the problem. Or, oh, I see X, Y up to here, yeah. I'm gonna switch this back to WW first here. I think maybe that's right. Let's look at up to there. Okay, texture size of texture. So up to here in this expression, as this is collecting all of the patterns in the texture, all the subpatterns, so we're doing like the slicing action. Let me just draw this out. Because maybe it's been a while, it's been a hot minute. If you haven't been following the stream from the beginning, you might not know this. Okay, so we have this like texture here. And it's like a grid. Think of it like a grid. And all we're doing when we're extracting the pattern is we're basically extracting like almost like subtextures. Okay, we're calling them patterns. Okay, so we start up in this corner here. If the size of the pattern is 3, that means it's a 3 by 3 square. All right, so we go chunk. We take out this sub part of the texture, the blue part, and turn it into a pattern. We extract the pattern. Right. At the next iteration, so we start at 0, that's 0, so we start here, 0, 0. Right, at the next iteration, we're going to go 1. Right, and maybe we'll do 1 and then 0. Right, that would be starting here, and this subpattern. All right, let me do it in a different color so you can kind of like what I'm doing. So the second step would be extracting this as a subpattern. Okay. That'd be 0, 1. Now up to texture size of texture. So this, the texture size here, I'm guessing for now should also be square, but I don't know if it really has. Well, our input image will be square, or should be anyway. So this might be a square thing. So ignore this, that there's a rectangle in my drawn out example here. So in order to keep us from looping back around to 0, 0 again, if we go to texture size texture, what we would get to from what 0, if we took out the -1 here, pretend that didn't exist. We go from 0 up to the size of the texture. So if it was like a 10 by 10, it was 0 up to 10, and that's inclusive in this range, right? As we just showed in the REPL. So we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 would be not one we want to index into. So I think that's why the -1 is there. Hopefully that makes sense. So we really want to just extract all of the subpatterns once. So along the x-axis, so for each column, we want to go up to the texture size -1. And same for each row. That way as well, extracting the subpatterns as we go. Well, 9 is the right length. Pattern result P's. What's the second pattern result P's length? What are we doing length of P's -1 is result there? I'm pretty sure I'm just getting distracted here, but just curious. Why did I put that way? Max index. Okay. We'd probably use that somewhere, hopefully. Yep, we use it there. In making a cell. Making the pattern enabler account. We use it in a few places. Okay. Checking the pattern. Yeah. We don't pass up to into extract pattern. Just the subpattern size. I swear I've encountered this. Data array, Haskell. Okay, now we got error in array index. Okay, so now something is looking it up. Error in array index. Frequency map. Yeah, okay, so maybe this is being constructed properly. Error in array index may be in the frequency map calculation. We're reaching into that array and giving the wrong index. Uh, 91. The max, yeah. The max index. There might be code, yeah, that could be doing that. Only one failure at this point. Just in the frequency map. But the main test is passing now. That would always work, because repeat true is always an infinite list. And I think list array is inclusive. That should be the final index in it. That might be fine. We do that again here for the enabler counts. Both of those are inclusive. Here and here. A 423 and a 424. And how do we use it here? Pattern index is less. This is get pattern from less than 0, or it's greater than the max index. Well, now it could be greater than equal to. Or if we're saying it's max index is inclusive, then that would be. This would make sense. That would be out of range. But I don't think we actually use it to actually index into anything at this point. It's just for bounds. We don't even seem to use it as a guard or an index lookup. So, well, actually this is using it for a guard. There's one area here. So this could throw if our guard is wrong. List bang bang. Where is this code? This is make output texture. So I don't think that test is calling into this. Yeah. You still get off by 1 errors quite a bit when using arrays. That's just array life. At least you get a few more initialization errors with using arrays in Haskell than you would with C. Catches a few more things like that. I wish it was a little bit better with... I mean, it would be a hard problem to solve. I don't think you could do it with the simple type system, but like bounds checking for accesses would be super dope. But obviously I don't think Haskell does that, or at least this library doesn't. Maybe there could be a dependently typed array library that could. Okay, so I don't think it's that there. Where the heck is frequency hints? Indexing. Like, I'm not seeing it. Pattern matching down the list. And the Go accumulator doesn't even touch pattern result. Doesn't construct an array. So how the heck is that test? Oh, it's calling patterns. Okay, that's why. So clearly we're missing a test for this patterns function. Because that's what's actually throwing here, I think. Well, this is getting caught, you know? At least that. Okay, so cum elums, this could be... This is indexing, so this could be where the error is coming from here. So we use accumulate here in the texture elements in the fold L over indices. We index into texture, which is texture array, which we get as input. Yeah. Let's just print some of those out. And then it'll probably maybe become obvious. Text and show that. And show the index we're trying to index into before we get the error. might demand a show A up here. I'm just going to preemptively add it. Gonna show here. Okay, we seem to be happy. It's generating a ton of data because it's in a property test here. So it's just humming along. It's probably a bit slower than it normally would be. It has been because it's got to print out all this stuff. I'm just going to stop it. Example, this way goes from is going to 0, 2. I was trying to get 0, 1. Like 13, 13, 0, 0. I'm trying to get a 2, 2 there. Interesting. Interesting. We should be seeing these go higher. And they're not, because we're modding the size. And that's the sub-pattern size we're modding on, not the texture size. That's wrong. It's not the right type. Let's bind that. Okay. All right. So extract pattern should be, if we're using size here, that should be the size of the texture we're modding on. W here. W is no longer right. Okay. We do want this to be the pattern size. We do need the pattern size in there because we don't want to. We want to get those texture values out into our sub pattern, and these indices are supposed to be the real indices into the texture, but we're getting, it looks like we're getting like just 0, 1, 2, 0, 1, 2, 0, 1, 2, despite the size. Like, I'm not seeing any 1313s subpatterns here. And if I take out show texture here, so we just spit out those indices and QMLMs. And let's focus the test to just the frequency map prop. Oh no. Windows is screwing up on me again here. Or not Windows, Power Toys, whatever. Somehow has managed to set... Oh, Christ. No, that didn't work. That's probably the wrong one. Key map state. Turn. Okay, that's better. Turn that back on. There we go. Okay. Focus that. Alright, now let's run this. And I don't think we're gonna see anything greater than like 2.2. No. All 0, 1, 2, 0, 1, 2. So that's all that we get for indices here. Over and over again. Okay. Uh-oh. Shoot. That's annoying. That's what I get for using a mouse. Okay, so... we're not getting 0, 1, 2s. Well, we're only getting up to 0, 1, 2s. Until we get our failure. 2, 2. Yeah. And so we get... it's shrinking down the texture size until we can't... until we get this error, basically. Then we can't get in there anymore. It's like if we do a 3x3 pattern size on this texture, then it's starting to go bleh. Can't. That's what's happening. Yeah. That should be fixed, but I'm gonna just kind of punt on it for now. I don't think it's going to block like the actual algorithm from working. I don't think. It's just a minimum texture size thing with the hard-coded pattern size issue. Alright. Let's see how that has affected the program. And the output we get. Okay, still kind of junky output, but yeah. I don't think any of those colors actually appear, so we might still be kind of like stuck in what the F land in terms of the data we're getting. Gonna get rid of the debug.trace here. Okay, so our algorithm is running. It's copying data from the input texture to the output texture, which only leaves our get data functionality as a potential culprit for the reason why we're getting weird pixel value data stuff. Right? So getPixel here is taking a cint index. That index is supposed to be an offset into the array of pixel data. Okay, we're getting a pixel point. We're getting a pointer here. This is almost like the raw pointer, the void pointer that we're casting to cuint. So an array of 32-bit unsigned integers. And peak element offset, I think the type of that, that comes from foreign.storable. Foreign.storable. Peak offset. Peak element off. Pointer a int. Okay. It's not a cint, a Haskell int, so the from integral from or that should be fine. Should be. It's for small values, I think that'll be fine. And well, no, actually, sorry, I'm thinking more of like the platform dependence. Haskell is the same kind of thing as that C does with like unsized platform dependently sized types like int. I guess in the general case for a lot of programs it doesn't matter a whole lot, but well, it's kind of... Anyway, yeah, peak element off. So that takes an int. So our index here into the offset could be wrong. Get pixel here. So we're going from 0 to image width times image height minus 1. Not inclusive. So I would expect if we look at this input texture here, which I think when we run the program we output it, we should see the pixel data kind of look like our PNG. Which, again, this is super blurry because it's a crappy image viewer that doesn't really do zooming, but there should be, like, I think if you could see this, it should just give you an idea that there should be, like, some blacks, which would be 0. These greens values, however they're encoded in the 32-bit number there. We should see a smattering of these blue values, some red ones here, so like there should be quite a bit of zeros, but like dominating by a bunch of other different numbers. Dominated probably by zeros, a lot of zeros. If it's loading that properly and we're doing the conversion properly. Okay, and so our input texture, we do see a lot of 0s. The first non-zero we encounter is this number here, 383-866-4448. Followed by a different one, 3 different numbers. See if I can find this image here. Oh, lovely. Let's open Sprite. A better image viewer here. There we go. Oh, this has the same problem. God Lord, I don't care about AI features Windows. Stop putting them in there, Microsoft. Okay, so that's I have to open with Can I open it with Krita and zoom in properly here? We're about to see. Yeah, okay. So we should see like one whole row of zeros. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 zeros, plus a bunch more, and then 3 of the same value in a row. That's the only, like, as soon as it changes from 0, it should be 3 whatevers. So there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, right? Let me draw but not draw. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, sorry, 12. 10, 11. Ooh, we only got to well, with 0, that's 12. Okay. Then we get the next row. Oh, this is actually, this might be the issue. I'm treating this element here in this tuple as X. And this is Y. PNG, as we were reading the spec earlier, row by row. So these are flipped. Oh wait, no, wait, this is fine, actually. No, but I am treating them as XY, yeah. So we're increasing Y here first. 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we're increasing X for the first time here. So yeah, I think what it is we're getting the pixel data, we're reading the pixel data in the wrong order. We're still within the dimensions of the pixel data array, but reading them the wrong way. This is like turned the wrong way around. I think it's what's going on. If that makes sense. I think that makes sense. We're running out of time here. I was hoping that we would have this would be over pretty quick. We'd have time to prepare for Advent of Code. Well, that's okay. I'm still not really sure if I'm gonna actually do it this year. Do you do Advent of Code? Are you an Advent of Coder? Okay, let's see. So, if that theory is true, then we just have to come up with the right indices. That's all. In the right order. Yeah. I don't think I have ever finished it myself either, actually. I get about... Some years I get up to about the halfway point, and then I'm like, meh. And I don't know if it's like a skill issue, like maybe I'm just not much of a... Like, I don't really practice competitive coding, that style of coding, so... it's just not my jam. Like, the first batch of puzzles are, like, at just the right size that I can finish them, like, in an hour or two. And as soon as the problems get outside of that bounds of an hour or two, it's when I'm like, I don't have the time for it. Because I got too many other things to do in life, that, like, more than 2 hours is too much. Yeah. Yeah, same Swarm. Same. Okay. So the problem is that potentially we are not getting the pixel data in the same order that we're loading it into the texture when we construct the texture from the surface, if that makes sense. Okay. Because the pixels we're getting here are... I think this function here, this sequence is fine. I think it's probably in our texture from list function. Okay. So we're probably this is probably generating the indices. You're probably using a list comprehension. And it's not taking into account the columnar order that the pixel data is in, or the row-oriented order that the pixel data is in this list. And so it's just like it's just transforming it in a weird way. Okay, we're doing a straight array.list array from 0, 0 to size -1, size -1 of x's. Oh, That is interesting. So we're constructing a two-dimensional array from this flat array. What we end up with isn't what you'd expect. And what we expected, what I expected, yes, when I wrote this. So is it chunking it? Or is it doing like a straight through zip? Yeah, it must be this straight through kind of zipping list array must be doing some kind of zipping here with these indices. So it's increasing this y index here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 12 indices here. And then it's increasing x. And then y again. Okay, so I think the solution here will be not to use list array, but to construct our own list and construct it with our own indices. I think. Can we do that? Yeah. Okay, so we could construct our own list here with the indices in the appropriate order for the file format that we're reading here. And hopefully that will load up the pixel data in the correct orientation for the input texture when we go to chop it up. That would be good. And then I think we're still kind of getting some weird conversion issues with the pixel data, but yeah. All right, I think we're gonna have to call it there though. So I'm gonna put a little to-do note on that. No, I'm not gonna put it in all caps. Load the pixel data from that array that indices properly in row oriented. Zip. Zip with row oriented indices. There we go. The texture is turned weird. Is rotated. There we go. Okay. Let's make a little committee commit of what we've built so far. I think those shows are redundant. Just go remove those. Okay, comment, some change the pattern results, some change the output. Oh, output texture has one too. And a debug trace we can get rid of. I see that. Trace end. Yeah. Oh no, it was a removed trace end. Okay. Cool. Cool, 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 cool. Okay, and then I don't know what to call this commit. When applied, this commit will fix off by ones. Remove debug stuff. Okay, so all the code for this project that we've been working on tonight is up on GitHub. I am your wonderful host, Agent Ultra, and on GitHub I am also Agent Ultra there as well as on Twitch. So you can find the code there, Agent Ultra /wave function collapse. chat. Paste that for you. Of course, you can also find me on the Fediverse as well. I'm on the types.pl server on Mastodon at Agent Ultra. And I'll copy that. Let's paste that as well. If you go there, you can find links to all my other stuff. So I got a YouTube channel where I back up my VODs, my own website, which links everything else, and all that sort of stuff. You can also follow me here if you're on Mastodon and you want to get updates on the stream. Sometimes I post about the stream and when I'm streaming and stuff like that. And all that stuff. You can also, I do these streams on Tuesday evenings, about 10 after 8 in the evening on Eastern time zone. So if you want to like write that down and follow along, you can certainly do that. But if you're the person who likes to have notifications and stuff, give us a follow here on Twitch, or if you're on YouTube, like and subscribe. And you'll get notified when you have notification settings and preferences all set up when I go online. Sometimes I might do extra streams here and there every once in a while. So it's good to know. And what else? Oh yeah, go to the link above my head. Discord. There's a Discord server on this website. Check it out. There's a channel there on the Discord server for this stream, where if you're watching the VODs and following along there, or if you just want to chat between streams and talk about your projects or whatever, we can talk about them there. There's also a lot of cool other people doing streaming in different programming languages other than Haskell, but also Haskell as well. So check out declarative.tv. And that's all I got for you this week. So thanks again for watching and following along. And we'll see you Tuesday next week. May all your monas be free. Your types always check. Happy hacking out there. The stream is over. I just have to figure out how to turn it off. Take care.